In this lecture, we will cover the analysis of variance, the F, also known as ANOVA table, the ANOVA analysis, which produces an F test, and I'll come to that later on in the lecture. But first, let me remind you, when do we use the F? So you've seen this before, um, and we covered everything except for when you have three or more groups and your outcome is numerical right here, and either your groups are independent or dependent. In both scenarios, you're going to use the ANOVA analysis of variance F-test. The only difference between the two is whether you use or you do not use blocks in the system. Okay. Before I'm going to go through the lecture itself, I would like to spend a little bit of time explaining the rationale behind the analysis of variance. So think about it this way. Think about a set of data that has, let's say, it has so a lot of variability. Okay, so this is your set of data, and it has a lot of different values. So there's a lot of variability. And by now you remember that we measure variability through the standard deviation, right? So it's the standard deviation, um, which itself is based on the, you remember the sum of square, which is divided by the degrees of freedom. Now, if I square everything, so if I leave this without the square root and I square the standard deviation, that's the variance. Okay, so this is just a quick reminder of what the standard deviation and variance and sum square, etc. Okay, so think about the set of data, and let's say after you have the set of data, you decide to group it by to look at the three. Let's say you had three groups, and you want to look at the three groups. And when you started looking at the three groups, you notice that the first group, the set of data for the first group is like probably here. The set of data for the second group is like somewhere here. And for the last group is somewhere here. Okay. I should have used a different color. So somewhere here. Okay. So the whole set of data, when you put everything together, you were seeing just a one lump. But when you start putting things by group, you see like a group here. Okay. And then you see another group that is here. And then you see a third group that is here. And obviously you can see that, well, if the average of this group is somewhere here, the average of that group is somewhere here, and the average of that group is somewhere here. Obviously you can see that the averages are far away from one another. And the other thing that is happening is you're seeing that there's not a whole lot of variation within every group. But when you put them together, you got a lot of variation because the data is aggregated in such a way that group 1 is on the top, group 2 is in the middle, and group 3 is on the bottom. And so when you put them together, you see this data that has a wide spread. But in fact, this wide spread is due to you know, the differences in the group. What I'm trying to tell you is maybe there's no easy way to say it. I'm just going to go ahead and say it, is that this whole variability that you've seen here, this whole variability is actually due to two things. First, it's due to the within variability in a group A. So if this is like group A, group B, and group C. So how much variability there is within A, how much variability there is in group B, and how much variability there is in group C. So variability is differences, right? And you can see there is not a whole lot of variability in A, B, C. The second source of the variability is coming from how much variation there is between a group 1 and a group 2, group 1 and a group 3, and group 2 and a group 3. Okay, so and here you can see that there's a lot of variability, there's a lot of differences. So these groups are quite far away from one another, whereas inside the group there's not a whole lot of variation. Let me show you another setup so maybe it becomes clearer. So let's think about what if I start up with the same setup where I had, you know, this is the whole set of data here, okay, and this is like the variability. But this time when I start splitting it into the three groups, I see something like this. Okay, so maybe this is a group 1, and this is a group 2, and this is a group 3. And you can see that now within a group 1 there's a lot of variation, within a group 2 there's a lot of variation, within a group 3 there's a lot of variation. And if you were to compare the means maybe are not that far away from one another, so there's not a lot of variation between the groups. Okay, so again, one last time to just explain the idea. I'm going to show like a perfect setup, like in a perfect setup. This is the entire set of data. And if you were calculating the variance, which measures the variability, remember? So this is the sum of square over degrees of freedom. And you're not taking any square root. In a perfect setup, group 1 will be right here. Group 2 will be right here. And group 3 will be right here, right? Like there's almost no overlap between the three groups. In another perfect setup where so in that setup you see that the total variability that you had over here, most of it is coming due to the differences between the group. And the reason it did, if you put them together, the data is so much spread out, it's because of the differences in the group. Whereas within each group, there's not a whole lot of variability. I mean, if you put them one next to the other, there's not a whole lot of variability. But because group 1 has a very high average and group 2 in the middle and group 3 is on bottom, you start seeing that altogether you get a lot of variability. Another setup is if you look at something like this and then you come to group 1 and you see group 1 is spread like here, group 2 is spread like this. Sorry, I should have used the blue. So this is a group 2, sorry. Okay, and group 3 is right here. It's not picking the color right. It's not picking the color. Okay, so in group 3 is here. And you can see that when you're looking at it this way, you see that they're all kind of have the same average. There's not a lot of difference between the groups, but there's a lot of variability within the group. Okay, so if this is not clear, let me just say it one final time, so that the idea behind the analysis of variance is you have a set of data, okay? If you want to calculate the total variation in this set of data, it's the sum of square divided by the degrees of freedom, okay? Now this sum of square right here, okay? This sum of square can be attributed to two sources. One is what I've been calling the within, writing within wrong. So one is within the groups, how much variability there is within the group, and the second source is how much variability there is between the groups. Okay? And obviously when you start seeing the group splitting apart, so when you see, so for the between, I showed you two scenarios. One scenario you had the group up here, second one right down here, and the third one right here. So that produces a lot of between. The between would be very large, okay? But the within wouldn't be that large. That's scenario 1. Scenario 2 that I showed you is when you see something like this, right? So there's not a whole lot of between, okay? They're kind of like very similar to one another. So the between is small in this scenario, but the within, so within the group 1, within group 2, within group 3 is very large. And what the analysis does, it actually compares how much contribution the within versus the between is doing to the total variation. And obviously is if between the groups is contributing much more than the within, then that means you have a scenario like this one, and that means that the groups are different. Whereas if the between is not contributing a lot versus the within, then you have a scenario that looks like this, and that scenario means that the groups are not different. Okay. All right. So let's see if we can go to our uh, to the lecture, and we go over the lecture with the example. Hopefully that would shed some light and make things easy to understand. All right, so here's the lecture. Introduction, analysis of variance. Okay. And oh yeah, so I started up with some reminders so that you kind of like remember what the sum of square is and how it works. So okay, so I'm gonna go back and give you a quick reminder of what is the sum of square. Hopefully you'll remember. We've been doing a lot of work. So um, we covered previously that variance is nothing but the standard deviation square. Okay, and what is the standard deviation? The standard deviation is the sum of squares divided by the degrees of freedom, and you square root that, right? Okay, and previously we also mentioned that out of this you can figure out that if you want to calculate the sum of squares and you're given the standard deviation, that all you have to do is take the standard deviation, square it, and multiply it by the degrees of freedom. Okay, so remember this one, remember the formula of the standard deviation as well, and remember that squaring the standard deviation gives you the variance. Also, remember what is the sum of square? It's the summation of squares. What squares? Well, it's value, any kind of value, minus the average. Okay, you square the difference. So you're squaring the differences, and then you're adding up these squared differences. Therefore, it's called sum of squares. Okay, so I hope that's enough as a revision. Let's go back to the lecture. And the larger the sum of square usually means that you have more variability in the data set. But I've also mentioned early on in the lecture that comparing sum of square only is not fair because sum of square, according to the formula, is just a summation. So if you remember the sum of square, you're summing up squares. Okay. Okay. And while yes, sum of square is a measure of variability, a better thing to do is to correct it for the degrees of freedom, and that's where the variance comes for, right? So we correct for the degrees of freedom to get a better idea of the variability in the data. Okay? All right, so I think this is enough as an introduction. Let's start with the lecture. Okay, so what you have here is you have a 15 observation of a blood pressure. Okay, and so I just calculated the average, which came out to be 120.82, and I calculated the sum of square, which came out to be 510.12. So how did I calculate the sum of squares? Easy. You have the average 120.82. You take every value minus the 120.82, and you square. Then you come to the second value, 124.65 minus 120.82, you square, plus 120.16 minus 120.82, you square. And you do that for all 15 values. It will give you the sum of square equals 510. Notice here, the 15 values are put in only one group. I'm not differentiating yet between the groups. So this is called the sum of square total. Okay, it's like this is the maximum amount of sum of squares you can squeeze out of these 15 values together. You can't squeeze anything out of these 15 values. Okay, so next what I did is I introduced the grouping variable. Remember, grouping variable is your independent variable. So it turns out that we have 3 drugs, and every 5 individual in this study is on a certain drug. Okay, so the next thing I'm going to do is I'm going to sort by drug. Okay, so now I have the 5 individual on drug A together, the 5 individual on drug B together, and same thing for drug C. And these are the values of the individuals on drug A, of drug B, and drug C. All right, so what I did next is I calculated the average for drug A, and it came out to be 126.8, the average for drug B 120.7, and the average for drug C, and it came out to be 115.0. Okay. Okay. Next, what I did is I calculated the sum of square for drug A alone, for drug B alone, and for drug C alone. How do I do that? Well, it's pretty simple. If we go back one step to the previous slide, remember I had the averages. You can get the averages by just adding up the 5 values and divide by 5. Now what you do is you take the 126.8 minus 123.3, you square 126.8 minus 127.3 you square, and you do that for all these. So all the A values, you subtract their own average and you square. That will give you the sum of square for this group alone. Then you do the same thing for the second group alone, and then you do the same thing for the third group alone. Okay, so what that gives me, it gives me the sum of square within A, how much variability there is within A, the sum of square for B, how much variability there is within B, and how much variability there is within C. Okay, so within A, within B, within C. You add them up, you get the sum of square within for these three groups together, and it came out to be 157.8. Remember, the total sum of square was 510.12. Out of this 510.12, 157.8 came from the within of group A, group B, group C. All right, what about the rest? The rest is due to the differences between the groups. So we say the sum of square between the groups. Okay? So the entire sample, sum of square was 510.12. The sum of square within each group, for each group, we add them up, we get 157.8. The rest, which is 352.32, is due to the differences in the group, or what we say between the group, as I mentioned in the introduction. Okay, so now I have the total sum of square that is split between and within. Okay, so the sum of square total is allocated into two sources: the sum of square within the groups and the sum of square between the groups. Now let me remind you that if the sum of square between the group is very, very large, it means that the group's averages are different. So if the majority of the sum of square is coming from the between, it means that the groups are different, whereas if it's not contributing a lot, then there is no difference. So to calculate the between, yani sum of square between, we can dissolve the variation inside the groups, since it will account for that in the sum of square within. Okay, so let me explain a little bit here what this is. So I kind of like, I'm going over how you can calculate the sum of square for every one of them. So far what we have the sum of square total. That sum of square total is split into sum of square within and sum of square between. And I'm just gonna want to make sure that you know how to calculate every sum of square. So sum of square total, how can I calculate it? Well, either use the formula, which is the summation of every value minus the average, but here it's not the average of group A, wala group B, wala, it's the average of all the groups together. So either you call this the total average, wala the average of the averages, okay? Like a grand average, okay? That will give you the sum of square total. Or if you're provided with the standard deviation of the 15 value and standard deviation total, okay, well, all you have to do is square that standard deviation and multiply it by n minus 1. And n here stands for all the observation. And in our example, we had 15 observation minus 1. That will be the degrees of freedom. And you multiply that by the standard deviation of the 15 values. Okay, so you have two ways to get to the sum of square total. Okay, sum of square within. How do I calculate the sum of square within? Okay, so either you replicate what you did here, but this time for every group. So you do the average so you sum the differences. So, but here you're not taking all the x's, you're just taking the x's in group A minus the average of the group A, okay, you square, and then you add to that the sum of squares for group B. So you do, I'm calling this B, يعني بس ال x's for the B minus the average of group B, you square, plus you do the summation of x group C minus the average of group C, and you square. Okay, so that's one way to do that. Another way to do it is take the standard deviation of A, square it, and multiply by the NA, and in the number observation in group A minus 1, plus take the standard deviation from group B, square, times the degrees of freedom of group B, which is NB minus 1, plus standard deviation of group C, square it, and times the degrees of freedom of group C. Okay? So like we did for the sum of square total, there is where you either sum the squares or you use the standard deviation squared times the degrees of freedom. For the between, you have two options. Either you're going to do that for every group by itself, group by group. So you're going to sum the squares within group A, sum the squares within group B, sum the squares within group C. Or what you can do is utilize the standard deviation of group A, standard deviation of group B, standard deviation of group C. How do you do that? You square the standard deviation and you multiply by the degrees of freedom of group A, which is the numbers in group A minus 1. نفس الشيء for B and نفس الشيء for C. You add these together. By adding these two together, three together, you get the sum of square within. That leaves us with the sum of square between. Okay, so how do we calculate the sum of square between? Let me clean up a little bit and I'll explain that. Okay, so remember when I told you that at the beginning it's like you have a set and then you split the set per group. So you had the group A, group B, and group C. And then the variance within A, within B, within C. And then you wanted the between is like the differences. Okay. When we calculated the sum of square within, خلاص, we accounted for the within. When you come to calculate the sum of square between, you only want to calculate the sum of square between the group. You're no longer interested in what is happening within the group. Therefore, what you like to do is you like to eliminate the within. خلاص, you calculate it in the within. You don't need it in the between. How do you calculate sum of square within A? So if this is a group A, okay, how do you eliminate the sum of square within it? شو معناتها لما you eliminate the sum of square within it؟ معناتها ما بقى في variability within A. معناتها all the values are similar now. They're all the same, so you don't have a variability. So the question becomes, what value is best representative of all the value inside the group A? Well, we've covered that in the earlier lecture. The best representative of a set of data is the average. So what you're going to do is you're going to replace all the values inside A by the average of group A. Okay? And you're going to replace all the values inside B with the average of B. And you're going to replace all the values inside C by the values or the average of C. Okay, but this average of A is going to be repeated NA times, and the average of group B is going to be repeated NB times, and the average of group C is going to be repeated NC times. In our example, we had 5 in group A, 5 in group B, 5 in group C, and therefore the 5 in group A were going to be replaced by the average of group A, but you're going to have the average of group A 5 times, the average of group B 5 times, and the average of group C 5 times. Okay, but in case the numbers were not equal, then you have to go back to the number of observation inside of A. Okay, so once you replaced all the values by their averages, you've eliminated the within. How do we calculate the between? Well, what you do is you say, okay, the between is going to be the average of group A minus, remember, it's a sum of square. You're going to take a difference. That minus what? Minus the average of the averages. Okay? And you're going to square that difference. And you're going to repeat that how many times? Well, it depends on how many times you have NA. So you multiply by that NA. Plus, you take the average of group B minus the average of the averages, you square, and you multiply by the number of observation in group B plus the average of what's happening, the average of group C minus the average of the averages, you square, and you multiply by the number of observation. That is the sum of square between. Okay? So let's go back to our lecture. To calculate the between, يعني the sum of square between, we can dissolve the variation inside the groups. يعني we eliminate the sum of square within. We do not need it since it will be accounted for in the sum of square within. Reducing the variation inside the groups means that the x's inside each group will be the same. Which is the best value to replace the x's inside each group? Well, it's the average of that group. And therefore, I'm going to take the average of a group A, the average of group B, and the average of group C. Every one of them is going to be minused from the average of the averages, يعني the average of the 15 values. هذا الaverage of the averages, okay? So if you do 126.83 اللي هو average of group A, minus 120.8, which is the average of all the values, or the average of the averages, you square, and then you multiply by 5. ليش we multiplied by 5? Because we had 5 observations in group A. And then you do the same thing for group C, 120.66 minus 120.8 square. You multiply by 5, and then you do the same thing for group C, so 115 minus 120.8, you square times, you're going to get 352.31. which is exactly the value that we received when we calculated the total minus within. So go back one slide, go back another slide. Remember, the sum of square total was 510.12. The sum of square within each group مع بعضهم were 157.8. We predicted that the between was going to be 352.31, and sure enough, it came out to be 352.31. Okay. All right. So, so the total sum of square can be divided into two sum of squares, or two sources of sum of square. The sum of square within a group, this is the variability inside every group, and the sum of square between the groups, this is the variability between the groups. When the sum of square between the group is much greater than the sum of square within the group, this means that most of the variability is coming from the fact that the groups are different. And if you remember, the null hypothesis that we are testing was the average in group 1 equals the average in group 2 equals the average in group 3. And the alternative hypothesis is at least one of the group is different. So when you find that the most of the variability is coming between the groups, you can conclude that the groups are different. Okay? Okay, so let's look at another example. Here, it's actually the same set of data, the same اللي هن 15 observation of blood pressure. So the average of these 15, this average is what I've been calling the average of the averages later on. It's still the same, it hasn't changed, and the sum of square total hasn't changed. These are the same 15 values, so they shouldn't be different. But this time what I'm going to do is I'm going to group them according to eye colors. So they're grouped differently now. So those that have black eyes, that have green eyes, and those that have brown eyes. The average for the first group is 123.8, For the second group is 118.56, and the average for the last group is 120.8. Now, if I ask you to calculate the sum of square within the groups, what you should do is you take this, the 123.8, you subtract it from every one of these 5 values, and you square every time. You add up, بيعطيكم sum of square within black. You do the same thing within green, you do the same thing within brown. Okay, now here you cannot use the standard deviation options because I did not provide you with a standard deviation for every group. But have I provided you with a standard deviation? Now, for example, I told you that the standard deviation for group 1 was 3. What you need to do is you need to take the standard deviation 3, square it, so that's 9, and then you multiply by the degrees of freedom, which is 4. So 9 times 4 is 36. So the sum of square for that group would be 36 if you were provided with the standard deviation for this group. All right, so I actually did the calculation, and the sum of square for the black طلعت 271, for the green 73.73, and for the brown 92.10. Now this time around, if you look at the sum of square bit within, it came out to be 437.24, and you can see that this time the vast majority of the sum of square total went to the within, which means that the between will not get a whole lot of sum of squares. Okay. So so the entire sample sum of square was 510.12. The within came out to be 437.24, which left for the between 72.88. Now we could actually calculate, we can actually calculate that 72.88, but just taking the difference, that is perfectly fine. If you would like to calculate it, you could do it. I've shown you how to do it. You just take the average of the first group minus the average of the averages, you square, and then you multiply by 5. Again, why 5? Because we have 5 observations inside group 1. Same thing for group 2, same thing for group 3, and sure enough, you will get the value predicted, 72.88. So allocating the sum of square, this time when we allocated sum square, the sum of square between the group is not big as compared to the within, and therefore the conclusion this time is going to be that there's no differences when it comes to eye colors and blood pressure. All right, the allocation of the sum of square and the calculation of the sum of square is the key for ANOVA. This is the hardest thing to do. If you know how to do that, everything else is very simple. Let me show you what you actually have to do. Okay, so the 7 steps. كيف بيشتغلوا 7 steps? You set your null hypothesis and your alternative hypothesis. I've already mentioned this before. For the ANOVA, the null hypothesis mu group 1 equal mu group 2 equal mu group 3, all the way up to, I don't know how many groups you have. At least one of the mu is different. This is your alternative hypothesis. ANOVA and the requirement, it has some assumption. The first assumption that each group is coming from a normally distributed set of value. The second assumption that all group have the same sigma. Remember, this is the same assumption we made when we did the independent t-test. Remember, sigma 1 equals sigma 2 equals sigma. And that's what allowed us to pool the sigmas together to calculate the sum of the standard deviation pool. وآخر شيء إنه the groups are independent. This is true when you're doing ANOVA for independent groups, but when you're doing ANOVA for block data, this is no longer true. And then to calculate your test, yani step number 3 in the testing hypothesis, to be able to get to your test, you have to fill out the ANOVA table. So remember, ANOVA table is analysis of errors. So how does the ANOVA table works? All right. So عندكم the sources of variation, which is the between, the within, and the total. So with between plus within بيعطيكم the total. Next, you have the sum of squares, and this is what we have been talking so far about. We spend a lot of time explaining if the sum of square total is split between the between and the within. So sum of square between plus sum of square within بيعطيكم sum of square total. عظيم. Next, you need the degrees of freedom. Remember, what we need to do is we need to turn this sum of square into variance. So I actually want to calculate the variance between and the variance within. So how do I do that? Well, you need to divide by the degrees of freedom. So what's the degrees of freedom for total? Total, the degrees of freedom is just total sample size minus n, minus 1. You already know that. So in the example we were working with, you had 15. 15 minus 1 is 14. Okay, what about the sum of square for the within? The sum of square for the within is the degrees of freedom, sorry, the degrees of freedom for the within. It's degrees of freedom for group 1, degrees of freedom for group 2, plus degrees of freedom for group 3. And since the degrees of freedom for group A can NA minus 1, plus the degrees of freedom for group for B اللي هو NB minus 1, plus the degrees of freedom for group C which is NC minus 1. So you're going to have NA plus NB plus NC هولي مع بعضهم is actually the total N minus 1 لأول جروب وماينس 1 لتاني جروب وماينس 1 لتالت جروب, so minus 3, so minus K, where K is the number of groups. Okay, so again, one more time, the degrees of freedom for the within is N minus K. What about the between? Well, it's K, and the number of groups minus 1. Notice that if you were to take the degrees of freedom of between to add them to the within, you will get the total degrees of freedom. Okay, so K minus 1 plus N minus K بيعطيكم N minus 1. يعني لحديت هلا for the sum of square between plus within بيعطي total, for the degrees of freedom between plus within بيعطي total. Now you have sum of squares and you have degrees of freedom. What do? Well, you divide them, obviously. You're going to divide your sum of square between by the degrees of freedom of the between. So sum of square between divided by the degrees of freedom of between. That will give you the variance between. But for some reason, the people that developed this table ما سموها variance, سموها the mean, like the average sum of square. Well, we knew that. We knew that dividing the sum of square by the degrees of freedom gives you the average sum of square. We knew that, but we're going to call it the mean sum of square. You do the exact same thing for the sum of square within. And so you have the sum of square within divided by the degrees of freedom of within. بيطلع لكم the mean or the variance within, or the mean sum of square within. Now you can compare. Remember, we've been saying from the beginning that you want to see how much of the variation goes to the between and how much goes to the within. Now you can compare. The way you're going to compare is the one that is on the top is divided by the one on the top, on the bottom. So you take the variance of the between, you divide it by the variance of the within. I'm not going to use the word variance anymore. هستعمل the word mean sum of square between divided by the mean sum of square within, and that will give you the test that we're going to be using, which is the F test. بس لاحظوا, the F test is coming from a numerator and a denominator. The numerator has a degrees of freedom and the denominator has a degrees of freedom. Therefore, the F test has two degrees of freedom, a numerator degrees of freedom and a denominator degrees of freedom. Okay. And so next slide, this is exactly what I'm saying. The F test, it has made of two parts, the numerator part and the denominator part, and thus it has 2 degrees of freedom. Next is the F table. Okay, so here's an F table. This F table is only for alpha 5%. You have your numerator degrees of freedom on the top, and you have the denominator degrees of freedom on the bottom. So how does this F works? Okay, so first of all, like, look at the distribution, look at F, and look at alpha. Now let me go to Paint to explain how it works. Okay, now you remember when we were working with the T and the Z, again, the distribution used to be normal like this. When we calculated a Z, كنا نقول the p-value is this area here, and the mirror image of it, okay? So the blue was the p-value, صح? Okay. Now, when you're dealing with the F does not have a negative value. The F is a ratio of mean sum of square divided by mean sum of square, يعني variance divided by variance. And therefore, the F does not have a negative value. So ما في two-sided, في only one-sided. And I showed you a minute ago that the F has a distribution that looks like this. This distribution is for a certain numerator degrees of freedom and denominator degrees of freedom. Okay. So what they did is for a certain numerator and denominator, they came exactly where the 5%. So this is your 5% right here. ليش 5%? Obviously because this is alpha. And they found where the f, which f value delimitate the f, the alpha 5%. And they provided you with this f. Now this f is called the critical f. ليش اسمها the critical f? Because this is the f that delimitates the alpha 5%. So let's suppose this f came out to be equal and all to 3. In your calculation, if you calculated an f that came out to be equal to 5, yani your f is going to be here. Okay, so this is your f observed, your f calculated. Okay, and if it turns out to be equal to 5, then this f will produce this area as your p-value. Now compare this red area to the blue area. Remember, the red area is your p-value and the blue area is alpha. Okay, so in this specific situation, which area is bigger? Well, obviously alpha is bigger and p-value is less than alpha. It turns out every time your f observed is greater than your f critical, 5 is greater than 3, then this automatically means that your p-value is going to be less than alpha. On the other hand, if your f observed came out to be smaller than your f critical, so if your f observed came out to be equal to 1, for example, now this area, the orange area now, is your p-value. And how does the orange area compares to the blue area? It's larger, and therefore your p-value is larger than alpha. So in a nutshell, how do I figure out my p-value? What you're going to do is you're going to look at your f that you calculated from your calculation. So أنا f calculated أوقات بسميه أنا f observed, and you're going to compare it to the f that is coming from the table, which is called the f critical. Okay, تحت your f observed put your p-value, وتحت ال f critical put alpha. And no matter what the relationship is between these two, you reverse it for the p-value and the alpha. So if your f observed is greater than your f critical, that means your p-value is less than alpha. On the other hand, if your f observed is less than your f critical, that means your p-value is greater than alpha. Okay? As simple as this. Okay? So here we go. F observed greater than f critical, that means your p-value is less than alpha. Then we reject the null hypothesis and we say that we have evidence that at least one of the group has a mean different from the other. Furthermore, at least we can say that the group with the smallest average is different from the group with the biggest average. Because all you can say is at least one of them is different. We cannot really say where the difference is. Otherwise, it will require some more statistical analysis. If your f observed is less than your f critical, that means your p-value is greater than alpha. Here, you fail to reject the null hypothesis and you say that there is no evidence the group differences are statistically significant. So let's go back to our example with the blood pressure. The null hypothesis mu, blood pressure for drug A equal mu blood pressure for drug B equal mu of the drug blood pressure for drug C. At least one of the group has a mean different. This is the alternative hypothesis. We assume the alpha to be true and we assume the null hypothesis to be true and we set alpha at 5%. Okay? Step number 3 is building the ANOVA table, and I told you previously that once you calculated your sum of squares, everything else is very simple. So we've calculated the total sum of squares to be 510. We calculated the between to be 352.31, and we calculated the within to be 157.8. Come to the degrees of freedom. remember the total degrees of freedom is the total observation minus 1 يعني 15 minus 1 is 14. The within هو كمان total observation minus the number of groups. So 15 minus 3 is 12. أما between it is the number of group minus 1. 3 groups minus 1 بيعطيكم 2. Alright, once you see a sum of square and you see degrees of freedom, what you do is you divide your sum of square by your degrees of freedom to get you the variance, but we're no longer calling it a variance, we're calling it a mean sum of square. So 352.31 divided by 2 بيطلع لكم 176.16. For the between 157.8 divided by 12 13.15. So صار في عنا variance between, variance within, or I should say mean sum of square between, mean sum of square within. You take the top and you divide it by the bottom, you get an F of 13.39. Should degrees of freedom of this F 2 for the numerator and 12 for the denominator. طب هيدي ال F بنسميها critical ولا observed؟ هيدي ال observed or the calculated. Alright, now this F needs to be compared to the critical F. What is the critical F? Go back to the F table. Numerator degrees of freedom is 2. Denominator degrees of freedom is 12. So the F value or the F critical is 3.89. 3.89. I can go back to table. So I know that the critical F is 3.89 for alpha 5%. So my F observed اللي هي 13 is larger than the critical which is 3.89. So مثل ما قلت لكم بتحطوا ال p value تحت ال observed والalpha تحت ال critical, but you have to reverse whatever the sign is, and therefore the p value is less than 5%, and therefore we're going to reject the null hypothesis. The null hypothesis that used to say that there's no differences between the groups. Okay, so we reject the null hypothesis and we say that we have evidence that the three groups are not similar in terms of their blood pressure. بما أنه the lowest average is for drug C and the highest average is for drug A, we can at least say that drug C and A are different. Okay, now notice here I'm summarizing the data. I'm showing the averages per group and I'm showing the standard deviation per group. Remember, these standard deviation, you can use them to calculate the sum of square within. If you take 5.21, you square it and you multiply by 4, هتعطيكم the sum of square within A. You do the same thing for B, you do the same thing for C. You add them up, you get the sum of square within. But what about when we were working with eye colors? Well, you write your null hypothesis, your alternative hypothesis, you assume the null is true, you set alpha at 5%, and then you come to your table. بعدهم the total are the same, they haven't changed, but the distribution of the sum of square is quite different this time. 437.24 went to the within, 72.88 went for the between. The degrees of freedom this time also happened to be the same what we had previously, لأنه كان عندنا 555 into three groups. Sum of square between divided by the degrees of freedom between بيعطيني the mean sum of square between, which is 36.44. Sum of square within divided by the degrees of freedom of within بيعطيني the mean sum of square within. It happens, it's 36.44. I did not mean for it to be that way, but it happens. هلا بتحطوا the sum of square between اللي هي on top divided by the sum of square within, mean sum of square within on bottom بيعطيكم ال F. Again, this is the F observed or F calculated. The F critical has not changed بما أنه the degrees of freedom have not changed. But this time around, my F observed is less my F critical, which means my P value is larger than 5%, and therefore we're going to fail to reject the null hypothesis, and we're going to conclude that there's no evidence to suggest that mean blood pressure between those with the black eyes and green eyes and brown eyes are different. The difference observed is due to chance only. يعني هالدفرنس اللي عم تشوفوه هون بين 123 118 120 هالدفرنس is due to chance only. شو معناتها due to chance only؟ معناتها it's a sampling issue. It's not a real difference that exists in the population. Alright, so I have one more example before I finish the lecture using this. This time I'm going to use the standard deviation. Okay, so in the following study, the researcher was comparing 4 groups of bacteria. So عنده 4 groups of criteria: group 1, group 2, group 3, group 4. So I'm having 4 groups, which 3 groups, and he's measuring the mobility of the bacteria. So the data is shown right here. Okay, so عنده 2 bacteria for type 1, 3 bacteria for type 2, 4 bacteria for type 3, and 2 bacteria for type 4. And he's providing you with the mean of the motility for every group, and he's providing you with the standard deviation for every group. Okay, and we're asked to actually test the hypothesis. Is there evidence to suggest that that the difference in the mobility is statistically significant? يعني هل يا ترى the 8.5 is different from the 5, different from the 6, different from the 6? Okay. All right. So you know what we have to do? We have to calculate the sum of square within the groups. We have to calculate the sum of square between the groups and the sum of square total. Had we had the standard deviation of all the values, that would be easy for us to calculate the sum of square total. All right, so what I decided to do, first thing, is to calculate the sum of square within group 1, within group 2, within group 3, within group 4. ليش I started with that? Because I have the standard deviation. And I told you, if you have the standard deviation for every group, then all you have to do, square that standard deviation and multiply by the degrees of freedom for that group. So for group 1, you take 0.707, you square it, and you multiply by 2 minus 1, يعني 1, بيطلع عندكم 0.5. The second group, the standard deviation is 1, you square it, you get 1, and you multiply it by the degrees of freedom, which is 2. So you get 2. Then you take the group 3, standard deviation 1.826, you square it and you multiply it by the degrees of freedom, يلي هو 1, 2, 3, 4 observation, minus 1 is 3, and that gets you 10. The last one is 1.414, you square that and you multiply again by 1, and that gives you a standard sum of square of 2. So صار عندي sum of square within 1, within 2, within 3, within 4. I can add them up. بيطلع 14.5. This is the sum of square within. So first chunk is done. It's the sum of square within. Now I need to do the sum of square يا أما total يا أما between. Okay, so I either have to do the sum of square between the group or the total. Now to do the between the group, you're going to have to take the average of group 1 minus the average of the averages, the average of group 2 minus, as we have discussed previously, but I do not have the average of the averages. But can I calculate the average of the averages? Yes, I can. How can I do it? Well, you have two ways. يا أما you add up all the values, بما أنه you have them, and you divide by 11. That will give you the average of the averages very easily. Or what you can do is you take the average of group 1 and you multiply it by 2. That will give you the total of group 1. You take the average of group 2 and you multiply it by 3. That will give you the total of group 2. You take the average of group 3. You multiply it by 4. That will give you the total in group 3. The average of group 4. You multiply it by 2. بيعطيكم the total of group 4. And then you divide by 11. So that's what I'm doing here. Why am I doing it this way? لأنه you might not always have the actual values. يعني ممكن يكون عندكم situation ما عندكم هون. عندكم بس means with standard deviation. You can still get to the average of the averages. So 68 divided by 11 is 6.182. Next, what I'm going to do is I'm going to calculate the sum of square between. So you have the formula of the sum of square between. So I'm going to take 8.5 minus 6.182 square times 2. ليش times 2? Because I have 2 observation for group 1. Then 5 minus 6.182 square times 3 لأنه I have 3 observation. Then 6 minus 6.182 square times 4 because I have 4 observation, plus 6 minus 6 لأنه the average is 6 in group 4. Minus 6.182 square times 2 بيعطيني 15.136. صار معي the sum of square between. The hard work, the heavy lifting is done. okay لأنه adding up the between with the within بيعطيكم the total. okay so now I can fill up my ANOVA table. So the ANOVA table دايما تذكروا please that the source you start between بعدين within وتحت التوتال. So the sum of square between was calculated to be 15.14. The within was 14.5. You add them up, you get the total. For the degrees of freedom of the between groups, how many groups we had? 4 minus 1 بيعطيني degrees of freedom 3. For the within, how many total observation? كان عندي 11 observation minus 4 group بيعطيني 7. And for the total degrees of freedom is 11 minus 1 10. بس لاحظوا انه 3 plus 7 كمان بيعطيني 10. Alright, so you take the sum of square of the between, you divide it by the degrees of freedom of the between, you get the mean sum of square between, which is 5.045. Then you take the sum of square of the within, you divide by the degrees of freedom of the within, you get the mean sum of square within 2.071. The top one divided by the bottom one, this is your F calculated 2.44. طيب to get the F critical you go to the F table. هالمرة شو degrees of freedom 3 and 7. 3 numerator, 7 denominator. So I'm just going to go to the table. Here's the table. Okay, 3 numerator, 7 denominator. بيطلع معنا ال F critical 4.35. 4.35. This is the critical value. The calculated value is smaller than the critical value. معناتها ال p-value is larger than alpha. هون alpha طبعا is 5%. Therefore, we're going to reject the null hypothesis. So we're going to reject the null hypothesis and we're going to conclude that there's no evidence to suggest. عم بطلع لفوق بس لأرجع على التable ونشوف the values. Okay, there's no evidence to suggest that the mobility of these 4 types of bacteria is different. The observed difference is due to chance only. Okay. هلا the follow-up question could be, is a researcher suggest to increase the number of bacteria per group so that you increase your power? What does it mean and would that be helpful? All right, so let's go back to the drawing and you remember هلا هيدي التable لازم تكونوا by now very familiar with it. So you have reality here and you have the test here. So either the reality, the null is true, or the reality, the null is false, and you're either failing to reject or you reject. And I've filled this before. This is 1 minus alpha. This is alpha, also known as type 1 error. This is type 2 error, also known as beta. And this is power, okay, which is known as 1 minus beta. In our scenario, we failed to reject. So يا أما we made a correct decision or we made a wrong decision. Have we made a wrong decision? Would have been a type 2 error. شو معناتها type 2 error? معناتها in reality the null is false, but we were not able to reject it. How can you increase power? يعني how can you move from here to here? Increasing power. We have discussed this previously. 2 things can increase power. يا أما you increase your effect size, يا أما you increase your sample size. So in our example, if in reality the null was false, يعني if in reality there was a difference in the speed of the bacteria mobility, but we failed to detect it, increasing the sample size would yield to an increase in power, and therefore, hopefully, we will be able to change our conclusion and reject the null hypothesis and conclude that there is a difference in the bacteria. All right, so that concludes the ANOVA with the F-test without block. بيضل في عنا with block, which will be in our next video.